Hello students, today we are going to study the directive influence of substituent and their effect on reactivity. In the case of benzene ring, there is single mono substituted product is obtained. It is because of the equivalent hydrogen atoms are present in the benzene ring. All 6 hydrogen which are present in the benzene ring are equivalent. Because of that, if any of the hydrogen will be replaced, then there will be single same mono substituted product will be obtained. So what do you mean by directive influence of these substituent? So first group which is attached to the benzene will decide further attachment of the next group and on particular position. So this first group will decide which group will be going to attach on the benzene ring and at what position. So this is known as a directive influence of the group. So on the basis of directive influence of the group, there are two types of substituents or groups. First is Ortho-Para directing group and second is meta directing group. So first is Ortho-Para directing group. So what is happening in this case, as you can understand with the term ortho and para position. You know that what is ortho and para position in the benzene ring. So first group which is attached to the benzene ring will direct the next group to attach on ortho and para position. Because of that, these groups are known as Ortho-Para directing group because they are directing another group to attach on ortho and para position. So there are many substituents which direct another substituent to attach on Ortho-Para position. Example, alkyl groups, phenyl group, amine group, hydroxyl group, acetyl group, amide groups, halogens. These are the example of Ortho-Para directing group. So these group will decide further substitution of another group on benzene ring at ortho and para position. So let's see by the help of example in which there is a formation of Ortho-Para product is taking place. There are many reactions which we have studied in which there is formation of ortho and para product is taking place. Example, electrophilic substitution reaction like halogenation, Friedel-Crafts alkylation, acylation, nitration, sulfonation. These are the example in which there is ortho-para substitution is taking place. So let's see by the help of example why ortho-para product is obtained in the case of when these groups are attached to the benzene ring. So in the case of nitration, we know that there is use of nitrating mixture, that is concentrated HNO3 and concentrated H2SO4, by which there is a generation of electrophile, that is nitronium ion NO2+. This electrophile will attach on ortho and para position on the basis of directive influence of Ortho-Para directing group. So let's see in the case of so this is toluene. We know that in this case CH3 is example of Ortho-Para directing group. So this CH3 will decide which group will attach on and what position. So in this case nitration is taking place. So concentrated HNO3 in the presence of concentrated H2SO4 is reacting with toluene. So there is attachment of electrophile on ortho and para substitution is taking place. So there is mixture of products are obtained. So in this case, the mixture of product is obtained on the substitution of NO2 group. So what is happening in this case? This is ortho product, this is para product. So it means this CH3 group is directing electrophile to attach on ortho and para position. So in this case, the major product is para product. This is the major product, whereas ortho product is minor. So why in this case ortho product is minor, whether there is a two position of ortho, that is there are two ortho position and only one para position, is still the major product is para. It is because of the in ortho position the groups are attached on adjacent carbon. Because of that there is a steric hindrance. Steric hindrance is taking place. Because of that this compound is less stable in comparison to para, due to which the major product is para-nitrotoluene. Alkyl group is having ortho-para directing influence on the benzene ring. It means this group is increasing electron density at ortho and para position. So electrophile will attack only when there is electron rich site is present. So what is happening? This CH3 group is ortho-para directing group and it is also electron donating group. So what is happening? These groups, ortho-para directing groups, are increasing electron density at ortho and para position. It means ortho-para directing groups are electron donating group. They are increasing electron density in benzene ring. So because of that these ortho-para directing groups are initiating electrophile attack on ortho and para position. Because of that ortho-para directing groups are giving electrophilic substitution reaction. So why electron density is increasing at ortho-para position? Why it is initiating attack of electrophile? So let's see, it is explained on the basis of resonance. So what is happening in this case? If we take another example, so this is hydroxyl group, this is phenol. So what is happening? This is also ortho-para directing group. So why they are increasing electron density in benzene ring? Because the functional group, the atom of functional group which is directly attached to the benzene carbon is having a lone pair, except alkyl and phenyl. In this case the atom of the functional group which is directly attached to the benzene ring is having a lone pair. Because of that this lone pair is direct involved in resonance to the pi electrons of benzene ring. Because of this lone pair is in conjugation with the pi electron of the benzene ring, because of that this benzene will become electron rich, due to which these groups are known as a donating group, because they are donating their lone pair towards the benzene ring. So what is happening? If we draw the resonating structure, it will be clearly explained why electron density is increasing at ortho and para position. It means why electrophile is attacking on ortho and para position, not at meta position. So it is explained on the basis of resonance. So what is happening in this case? This pi bond will be shifting to this position and this lone pair will be shifted to this position, due to which there will be double bond formation between oxygen and carbon and a negative charge will come on this carbon. So the second canonical structure in which there will be positive charge coming on the oxygen, because the lone pair is donated towards the benzene ring. So only one lone pair will be left and negative charge is coming on ortho position. Next canonical structure, this negative charge will be shifted to this position and this pi bond will be shifted to the carbon. So the next canonical structure, this negative charge is coming to this position to form pi bond and this pi bond coming to the carbon to form negative charge. So there is negative charge on this position of the carbon, that is para position, and in this position there are pi bonds. Further this negative charge come on this position to form pi bond and this pi bond will convert to come to this position of the carbon as a negative charge. Further, next canonical structure, So in this position, this is also ortho position. In this position there is negative charge, pi bond on this position and at this position. Further this negative charge come on this position and this pi bond will come on oxygen. So there will be, this pi bond will be converted to the lone pair. Because of that, the positive charge of oxygen will vanish. So it means again two lone pair will be coming on the oxygen and there will be pi bond coming on this position. So there are 5 canonical structures which are formed. So these are the 5 canonical structure. As you can see, by the help of these canonical structure, it is clearly explained why there is high electron density at ortho and para position. Because of the resonance, because this oxygen is giving lone pair of electron, it is involved in the resonance, so it is donating its lone pair towards the benzene ring. Because of this lone pair is in conjugation with the pi electron of the benzene ring. Because of that, the electron density on ortho position and para position is increasing. Because of that, this group is activating benzene ring towards electrophilic substitution reaction, that is attack of electrophile, and on what position? That is ortho and para. Because negative charge is coming on ortho and para position. So what will be the final resonance hybrid which will be obtained? These functional groups, that is ortho-para directing functional groups, are increasing electron density on ortho-para position, that is benzene ring. So what is happening in this case? This circle is representing the delocalization of electrons. There is the lone pair of electron is delocalized in whole benzene ring. Because of that, the electron density in benzene ring is increasing. So the negative charge, this negative charge is representing that this benzene ring is electron rich, whereas the delocalization is taking place from this oxygen to benzene ring. So whereas in the oxygen there will be partial positive charge, because this oxygen is giving its one of the lone pair is involved in resonance. So what is happening in the case of alkyl? When there is atom which is attached to the benzene ring is not having lone pair. So what is happening in this case? Example, toluene. So what is happening in this case? In the case of toluene, that is CH3, when CH3 group is attached, this is ortho-para directing group. It means it is increasing electron density at ortho and para position. But in this case, the atom, that is the carbon which is directly attached to the benzene ring, is not having lone pair. Still it is behaving as ortho-para directing group. It is because of the hyperconjugation. In the case of alkyl groups, there is hyperconjugation is taking place. We know that what is hyperconjugation. We have earlier studied hyperconjugation. This is no bond resonance. In this case, there is a conjugation of sigma electrons of the hydrogen and pi electrons of the benzene ring. So there is a sigma pi conjugation is taking place. Because of that, there is no bond resonance, which is known as hyperconjugation. Because of this, the electron density at ortho and para position is increasing. In the case of, there are 3 hydrogens which are attached to the carbon. So what is happening? This bond of carbon hydrogen will shift to this position. Because of that, this bond will be shifted to this position. So there will be formation of, so what is happening? There will be pi bond formation. There will be double bond formation between carbon of the benzene ring and carbon of the alkyl, that is methyl. And this hydrogen which has donated its sigma electron will remain there in the form of a proton. This H plus cannot freely move because it is bounded by the electron cloud. Because of that, this H plus will remain bounded to this position. This is known as no bond resonance, that is hyperconjugation. Further, what is happening? This bond is shifting to this position, so the negative charge is coming on this position. Formation of So what is happening? This negative charge is coming to this position to form pi bond, and this pi bond will be coming to form negative charge. Further, this negative charge move to this position, and this pi bond will come to this carbon to form negative charge. So the negative charge coming on this carbon, and further pi bond will be coming to this position. Next, this negative charge will come to this position to form pi bond, and this pi bond will again come to this carbon. Because of that, this carbon will be having negative charge, so there will be again bond formation between carbon and hydrogen. So the next structure, so again there is a bond formation between carbon and hydrogen will takes place, and a pi bond is coming to this position. By the help of hyperconjugation, the electron density at ortho position is increasing and at para position. Because of that, these alkyl groups are electron donating group. They are increasing electron density in benzene ring. Because of that, they are activating benzene towards electrophilic substitution reaction. So electrophile will attack on ortho and para position in the presence of alkyl groups. So on the basis of the above points which we have studied in the case of ortho-para directing, there are two cases which arises in the case of ortho-para directing group. That is, if there are electron donating groups are present in the benzene ring, then this substituted benzene ring will show much more faster reaction in comparison to the benzene ring towards electrophilic substitution reaction. Example, in the case of toluene, this is toluene, whereas in the case of benzene, so in the case of toluene we have studied the nitration reaction which is occurring in the presence of concentrated HNO3 and concentrated H2SO4, which is nitrating mixture. Because of that, there will be generation of electrophile, that is nitronium ion, due to which there is a formation of, in which the major product is para product because of the less steric hindrance. Similar reaction will be taking place in the case of benzene ring, but in the case of benzene ring, this reaction will be slow. This reaction will be slow in the case of benzene ring because the electron density in benzene ring will be less in comparison to this toluene. Because in this case, this methyl is behaving as ortho-para directing group. So by the help of hyperconjugation, this methyl is increasing electron density at ortho and para position. Because of that, benzene will become electron rich, due to which this nitration will occur faster in comparison to this benzene ring. Second point, in the case of ortho-para directing group, greater will be the electron donating ability of the functional group which is attached to the benzene ring. Greater will be the reactivity towards electrophilic substitution reaction. Example, this is aniline, this is phenol. So in this case, there are two functional group. One is amine group, and in this case there is hydroxyl group. In this case, the electron donating effect of this amine group is more in comparison to this hydroxyl group. Why? It is because this nitrogen which is directly attached to the benzene ring is less electronegative, whereas oxygen is more electronegative in comparison to nitrogen. Because of that, this hydroxyl will not increase that much electron density in benzene ring as increased by this amine group. So on the basis of electron donating capacity of the group, it will be decided which functional group will initiate the reaction more faster in comparison to other functional group towards electrophilic substitution reaction.